key thing in that, which I've just got on this chapter, how that has been perpetuated is through the stories of Admiral Richard E. Byrd, which you might have heard about. Whenever you look for Hollow Earth, the second thing that will come up is Admiral Byrd's journey to the South Pole. And I studied those stories pretty closely, and it's absolutely true. Admiral Byrd, he did go to the South Pole. And indeed, there is a whole video about that. It's called Operation High Jump, and it was after the end of the Second World War. And it's a very interesting video. It's about an hour long, very well made for the Army or with the US Army and Navy. So it's, they had quite a budget for it. And they talk about how they took quite a large ship down there. And they actually had these planes. I think they had 3 or 4 planes which were taken off from this ship. But, you'd never do this now, of course. There's one particular bit in the film where they knew that the planes wouldn't be able to take off from the ship because it wasn't long enough sort of airstrip on the ship to take off from. So what did they do? They attached rocket bottles to the plane, all right, to give them extra thrust, lit those before it took off, and away it goes. And then the rocket bottles drop down into the sea, and they're away. And that's what they did, and it worked. They did it, and the film's there and everything.
No 3,000-foot runway here, only a scant 300 feet. Jet propulsion is their reliance. Crewmen attach jet containers, 4 to a plane. These JATO bottles are packed with flaming power. In the critical 10 seconds at takeoff, they give the kick-up of 2 added engines.
And they got to the South Pole, and then they got to the coast of the landmass, and then they went into the South Pole. And they found this particular region, and this story has been misquoted, it's still misquoted online, where it was ice-free. They found a region which was ice-free, and they found a freshwater lake near the South Pole. And they were able to land because they had one of these, what do they call them? Boat plane things. There's a proper name for them. I forget what they're called. Seaplane or whatever they call them. I forget the name. There's a proper name for them. And they were able to land on this freshwater lake, and check that it was fresh water. And they measured the temperature, and it was like, I think it was like 34 Fahrenheit. So it was above freezing on this freshwater lake. And they couldn't believe it, when they found this. And this has really been misquoted as a story that they found a fertile land and there are animals there and they met people. No, that bit's made up. That's come from a story. And in the book, I go into which story that probably came from. That bit of the story probably came from a film called Lost Horizon, which I think was made in the 30s. And you'll see, I've mentioned that in the book. So yeah, that bit's true. There was a region. In fact, no, I've got 38 Fahrenheit here, not 34. Not those. So it's 3 centigrade. This lake was, and this is right near the South Pole, and it was ice free, and that's true. So that bit is true. And so, some of the Admiral Byrd story is true. And also, for example, there is a volcano quite near the South Pole on Ross Island. So that, again, if you're talking about a warm, fertile land near the South Pole, well, what's a volcano? There's going to be heat. It's an active volcano, so there's heat there and lava coming out. So again, you might get a localized oasis of life around that. I don't go into that in the book, but you could look that up. So, there was some quite interesting bits of the story about things like Ross Island and stuff. And then, they talk about the missing diary of Admiral Byrd, and I found out that what actually happened was Admiral Byrd had kept a diary, but it was only released, I think, in 1999. And it was alleged that there were some secret things in this diary, and they only came out in 1999. And that's when I think a lot of these Hollow Earth stories started to get rebooted and reinvigorated, when this Admiral Byrd diary was released by his son or something, or his nephew, in 1999. And that I think some of that is online. I think you can buy it. You can buy the book if it's not available online. So again, added to these stories, of him going and meeting these people and all this, that, and the rest of it. But it's just stories, Yeah, and what I did want to mention briefly was that Admiral Byrd was one of the few people to attempt trips to both poles. Certainly, he attempted a trip to the North Pole in 1926, and I think the reason why this diary was kept secret is Byrd claimed to have got to the North Pole, right? He claimed in a plane he was flying up to the North, flying over it, in 1926 or 28. But if you read his diary, he didn't quite make it. He had an engine problem and he had to turn back. So I think he was like an hour or 2 hours from the actual pole. And the way he wanted to claim that he'd done it, but he hadn't actually done it. So that I think, reading between the lines, was why this diary was probably kept secret until quite a few years after he'd gone. Not because of they were covering up the whole polar hole stories and meeting all these, this other race that had come from the Hollow Earth. And the other thing as well, there was this North Pole Inner Earth expedition, which was organised by Brooks Agnew and another chap, I think it was called Steve Curry, back in, and I that was on Coast to Coast and everything. They were all set to go. 2012, I heard about this. So that was, eight years ago. And he said they got this ship, they hired this Russian icebreaker ship for like 2 weeks or 4 weeks or something, and they were going to take these scientists and they were going to measure the Earth's magnetic field, and, they were all ready to go down into the inner Earth and stuff, make these measurements. And I thought, really? When I first heard about it, I was quite interested, but then I thought, no, this is just bogus. And I don't know whether it was just some scam, because they raised about $2,000. But again, what struck me as odd is, didn't they ever pay attention to Michael Palin's documentary where he went to the South Pole, he went to the North Pole. There is no hole there. That's on record. You've got the satellite images by 2012, you have anyway, so I'm not sure. Maybe it was just another coast-to-coast type, New Age type scam, So that's the first half of the book, really. A summary of it is looking at, A, whether the Earth could be hollow, and B, whether there are these polar holes. And I couldn't find any serious evidence of these polar holes. Everything I looked at said they don't exist. However, the evidence for the Earth being hollow, there wasn't any evidence to say the Earth definitely wasn't hollow. There was only science which said it couldn't be hollow because, like the mass of the Earth is an issue, and then they claim that the seismic waves explain the structure. But Jan Lamprecht was good. That's where I thought was good. His work was sound. He said that another way of explaining these seismic waves is that it could be hollow. So then you're left with, well, maybe it could be hollow. So where do we go from there? And really, I'll switch to the other half of the book before I join the two halves of the book together. Because when I was looking at the Hollow Earth stuff and all the other stuff, I came across this other thing which people may have already come across. A chap called Neil Adams. Who's Neil Adams? Well, Neil Adams did a lot of the Batman comic art in the 60s and 70s and probably the 80s. So he's a comic artist. And he had a couple of other characters that he invented. One character I forget the name of. So I've never been particularly interested in comics and comic strip myself. I don't know about yourselves. I know some people are big collectors of it. So they will probably know Neil Adams' name if they're interested in the early Batman stuff. And so he's not a scientist. He hasn't got any scientific qualifications, but he claims he's always read scientific journals and stuff like that, and maybe he has. But the thing that he did do was he made some very compelling videos in 2006. And he describes them as being the growing Earth.
This is our Earth. we will be going back in time and watching the tectonic movements of the last 200 million years. We will not be applying subduction, rotation of continental plates, reducing, enlarging, sinking, or rising of plates, and only such turning, rotation as is justified by magnetic striping, like the rotation of Spain, Great Britain, and Central America. This Earth globe will reduce in size to accommodate the reductions of all the oceanic plates as clearly indicated by the rainbow map of the United States Geological Survey. This being the case, it would be impossible for these upper continental plates to fit together perfectly, and yet they fit together perfectly. We invite close scrutiny. Yes, there has been some erosion, landslides, and such, but the overall result is insignificant. We have been asked to believe that the continental plates drift about willy-nilly, bumping and crashing into each other like bumper cars in a carnival. This does not happen. Continental plates never collide. They only move apart, ever. In actual fact, they don't really move at all. The rifts of the lower oceanic plates move apart as the Earth fills and grows. Do the upper tectonic plates match perfectly in the Pacific as well as the Atlantic? Yes. Do plants and trees match across the North Pole in type and kind? Yes. Why is this obvious conclusion not considered by the geological community? Perhaps it is because the ramifications are so staggering to all scientists across all the areas of science. The outer 2.5 miles thick of crust of an early Earth, though slowly stretching, was all one piece, until the rate of growth grew too fast for the brittle crust, and 180 million years ago it began to profoundly crack and spread deep over the entire planet. We are now going forward in time to show how the actual growth of the Earth took place. Antarctica, 200 million years ago, was subtropical. Africa, rising up on a smaller globe, was originally way down under the globe. In fact, for 100 million years, Africa was the South Pole. South America's tail went under and wrapped around the bottom of Africa, then incredibly joined coast with Antarctica. 65 million years ago and more, these continents were joined, and monotremes like the duck-billed platypus roamed from Australia, Antarctica, and across southern South America and up into Africa. The platypus. Dinosaurs roamed all over this world on the upper tectonic plate because there were no oceans, just shallow seas. Here today, Antarctica is frozen over, and Australia and surrounding islands are the remaining home of monotremes and marsupials. Do you see how broadly the Pacific Ocean is opening as compared to the Atlantic? This is exactly why the knee-jerk Pangea theory exists. The Pacific spread is too difficult to visualize because it's so big. The Atlantic spread is so obvious that a child can recognize it. But they are the same. On this small planet were the shallow seas that covered 2/3 of the continental plates and have since completely drained off into the newly rifted open deep oceans. These shallow seas on the continental plates hold every scrap of evidence ever discovered of ancient sea life of the Earth. Those shallow seas are completely gone now, completely drained off into the new rifted open deep oceans, lowering the actual sea level by 1/2 mile. Is this possible? The oceans have absolutely nothing to do with tectonic spreading, except that they cool the thickening mantle. Tectonic spreading, even according to the most conservative scientists, has created 2/3 of the Earth's surface in the last 200 million years. And therefore, the same must be true on all planets. Now I'm going to run the Atlantic and Pacific without rotating the planet. Honestly, there's no tricks here. I did nothing while the other side was turned away. Please examine this carefully. The outer, upper tectonic plates, the land fits together like a pulled-apart puzzle. No exceptions. There is simply no doubt of any sort that these land masses fit perfectly on a smaller planet, All our natural history tells us this. No ancient oceans existed. Now drained shallow seas hold the only undersea history that exists on Earth. Antarctica was subtropical. There were no frozen poles before 60 million years ago. If Earth was always the size it is today, we've got a problem, because 2/3 of the upper tectonic plate is missing. If subduction existed, and it doesn't, it simply cannot and does not explain anything at all. The evidence is overwhelming. It simply needed collecting and demonstrating. The Earth grew. No Pangea, no Gondwana, Laurasia, or Tethys Sea. No meteorite knocked off the dinosaurs, no vacuum in space, no Big Bang. If what you see before your eyes right here is true, the Emperor has no clothes, and everything in science must change.
Now, I ended up interviewing Neil Adams. Again, this would have been probably 2014, 2015, for reasons I'll get onto in a minute. But he basically produced these videos, and as he said, it all started for him when he was reading books about dinosaurs and stuff and the Earth and that sort of thing, and I was always interested in that. Mm-hmm. And then you look at the globe, for example, you look at a map of the world, and you can see, I think if I look at South America, I could see that fits into the coast of Africa. You could see it quite clearly, can't you?
I've seen bits of that. Mm-hmm.
That's pretty obvious. So, were they ever joined? And of course, in the standard model of the development of the Earth, they talk about Pangea, and then this is what this thing on BBC was really weird. It was on BBC this morning, which I never watched, just before I was going to see you guys and talk about it. So Pangea was this giant supercontinent where they say the continents as they are now, they were all joined together into one big lump. That was hundreds of millions of years ago, and then there was just ocean all around that lump of land, one single landmass, supercontinent called Pangea. That's in all the textbooks, And then at some point, this supercontinent Pangea broke up, and then it differentiated. So it became. Part of it became America, part of it became Europe, part of it became India and this, that, and the rest of it. And it slowly, the continents moved around, pretty much random, and there we are today. And they will tell you, and it was on this program today, and this bit is true, that America and Britain are getting 2 centimeters further apart every year, right? And I heard that figure when I was 12 or something, So then you start to get into the history of how that came to be known. How do we know? How can we measure across 5,000 miles the distance of 2 centimeters? How could that possibly be measured? Well, originally, of course, we couldn't measure that. But how this story began takes us down another, sort of path, really. Because it was in the 1930s that a chap called Alfred Wegener, who was a geologist, he started to develop this idea of what they call continental displacement. Continental displacement, he called it, whereby the continents are actually attached to plates, and these plates are floating on the volcanic kind of fluid, the mantle. So you've got all this volcanic activity going on underneath, and then you've got these, a bit like pieces of paper or pieces of card on boiling water or pieces of plastic on boiling water, and they float around, And this was Wegener's idea, and there were splits in these plates, and there was a oceanic plate and there was a continental plate, and and these would break apart and move around, but you couldn't normally see it because these movements took place over millions of years, So to move a mile might take 100,000 years or 200,000 years, and of course we only live 70 years, so fat chance we've got of seeing any of that, So you then have to look into the geological record, which of course was what Wegener was doing. And Wegener, I think I read that he died when he went to Greenland, I think. He was on a geological expedition to Greenland. Apparently, there's some amazing geology in Greenland, because that's been covered in ice for like 10 million years or 50 million years or something like that. And so Wegener died, I think, on a trip to Greenland. But he was poo-pooed, the continents that have never moved. No, the Earth, God created the Earth. The continents have always been there. They're moving around. And they called it continental drift, rather than, because he called it continental displacement. And really that then takes you to this. I mean, we could see it's blindingly obvious that the continents have moved apart.
Alfred Wegener, the first scientist that suggested that the continents are moving, was born in 1880 in Berlin, Germany. He was fascinated by Greenland, preparing at a young age for a possible expedition to Greenland. In fact, he made 4 expeditions to Greenland. He studied astronomy, meteorology, and finally, geophysics. He saw on a map that the 2 continents, South America and Africa, could possibly fit together, and fossils in South America matched with fossils in Africa. He also saw that some coal beds in the eastern U.S. were identical to the ones in Europe, and that South American, African, and North American mountain ranges matched with each other. When Pangaea divided 200 million years ago, there were what was believed to be 2 continents, Laurasia being a combination of North America and Eurasia, and Gondwana being everything else. In the early Cretaceous period, Gondwana began to split up into the continents we know today. India split up from Australia and crashed into Asia, forming the Himalayan mountains. This is still happening today. Sometime later, Laurasia split up, and that is how the Earth's continents are today. Wegener presented this idea to scientists, but the idea was not accepted. There were some who agreed with Wegener, but most did not believe it. The reason that Wegener's theory was not complete was that he could not find a force to move the continents. Wegener died in 1930 on his 4th expedition to Greenland. He was found buried in the ice.
So then it started, when the geologists started to get into this, thought, actually, you know what? This Wegener guy was right, the continents are moving apart. And by sort of about 1960, so fairly recent history, pretty much everyone agreed that that was what was happening. And really the thing that killed it was when they went down into the mid-Atlantic with a submarine, and they were able to, in a remote controlled submarine type thing, and cameras and whatnot, or no, maybe they didn't, I can't remember how they did it at first, but they were able to measure the ocean floor. And it was spreading, it was breaking apart. And they were finding rock, coming out of the volcanic vents, going into the water and then hardening, and that's what was causing the continents to split apart. They discovered the mid-Atlantic ridge. And that was the thing, I forget the exact date, I've put it in the book. So, they found this and thought, oh yeah, so Wegener was right. The continents are indeed being displaced. They are moving apart. So, realizing that this new landmass was being created continuously all the time, right? You're faced with a bit of a problem because if this ocean floor is spreading apart and it's coming out of the ground, the mid-ocean ridge at 2 centimeters a year, it's got to be being destroyed at a rate of 2 centimeters a year, hasn't it, as well? Because if it's not, what does that mean? If the land's not being destroyed and the continents are getting further and further apart, what does that mean? It means that the Earth is expanding, doesn't it? That's what.
Well, it does seem like it's other explanation.
Can't have that. Can't have that. So they came up with this idea of subduction, whereby around the other side of the planet, or different points, I think there's 2 or 3 points where they claim that this subduction is happening. The continental plate is being thrust down under another continental plate, and so any sort of 2 centimeters a year of expansion is being cancelled out because the 2 centimeters of land, is being pushed down at another plate boundary and getting destroyed and going back into the Earth to keep the Earth the same size, right? And that's what I was taught in geography. I remember first hearing that word subduction, and I mentioned it, describe it a bit more in the book. And I also describe one of the main pieces as evidence where they claim that that's what's causing it. They claim that what they've done is, you've got this bit of oceanic plate, continental plate going under another one, I think, and then they claim that some of that material is being destroyed and it's got various radioactive isotopes in it, and then those same radioactive isotopes are coming out of a volcanic vent, and they got the isotopes out of there, and that proves that this land is being destroyed and it's coming out of the volcanoes at some point. It's something like that. I've got it in the book, and I only came across that while I was putting this book together. So the geologists need this idea of subduction, which is the destruction of landmass, to keep the Earth the same size. All right? So, okay, yeah, fair enough. We'll give them that for now. But when you start to look at it, and going back to, I went on to Neil Adams, and then I broke off Neil Adams, you find that if when you look at a map of the world, you've got America on the left, as we draw it, and, Asia and India and whatnot on the right. What happens if you were to reverse that? If you were to look at it from the other side. So take a globe and turn it around so that you've got, it would be, I suppose, sort of India on the left, and then Japan, and then Russia and the west coast of North America on the right. You look at the other side of the globe. So wrap the map into a cylinder and look at it the other way around. What you actually find is that the continents fit together across the Pacific boundary the other way. So in other words, the west coast of America fits onto eastern Russia and China and all of that, and Japan. It goes across that way as well. So again, what does that mean? And as Neil Adams showed in his videos in 2006, the Earth has expanded. It's expanded. Now, okay, so it's okay, and he uses a CGI model. We all know about proof by CGI. I mean, that's what we've been subject to right now, isn't it? Proof by computer modelling. It's what's caused all this crap that we've been living through now. So you can't just go on the computer model alone. So what else can you go on? Well, how about some geology? Everyone says that, you've got various geological correspondences between, say, South America and Africa because of that join. Are there any geological correspondences between the western coast of America and, the eastern coast of Russia and, Japan and China and all of that? The answer is, according to James Maxwell's book, oh, yes, sir. Oh, definitely, because he's gone through all of that. He's written a book called Beyond Plate Tectonics, and I've been in touch with James Maxwell, several times. He was very kind because he just sent me a PDF copy of the book, and he's got quite a lot of free stuff online as well. And he goes through, for example, we talked about this problem of subduction, which is whereby the land is destroyed. He explains all of that and says, well, what they say is subduction. There are other ways of explaining it. And he basically says the Earth has expanded. He's looked at, for example, the ancient magnetic poles. Because the Earth, as you know, you've perhaps read this yourselves, the Earth's magnetic poles have moved. They've moved around quite a lot, and I think they've moved, 40 miles, since, 2001 or something. See this in geological traces where you've got magnetic ores, ferromagnetic ores. You can somehow measure where the Earth's magnetic field was, and in fact, going back to the ocean floor spreading, right? They found that if you look at the magnetization of the ores in this rock, they found that the Earth's magnetic field flips from north to south about once every 100,000 years. something like that. And so they can measure this. And so Maxlow's measured that in geology elsewhere in the world. And he goes through all of this in his book, and he shows you, and also the plant life. You've got the same plant life, same fossils going across these boundaries, same geological rock types going across these boundaries. So to me, it's conclusive proof that the Earth has expanded.
We're faced with the suggestion that increase in Earth radius is caused by an increase in mass. So where did all this mass come from? I don't know. But this is a speculative mechanism that I developed and put forward in my thesis. What the geological information tells us for the very early Archean era was that certainly mantle temperatures were around about 1500 degrees hotter than what they are now, and surface temperatures were between 30 and 300 degrees hotter than what they are now. You can only measure the age of a rock once the crystals in that rock have solidified and that rock has cooled enough to be preserved with time. So at that moment in time when that first rock solidified and was preserved up till the present day, and you then go and measure that, take measurements from that. Prior to that time, if that rock was molten, you cannot measure time. So basically our geological time starts at that moment when that first rock crystallised and solidified and preserved to the present day. So these high mantle temperatures and surface temperatures then suggested to me that during the pre-Archean, prior to 4,500 million years ago, for an indeterminate period of time, that the Earth was actually molten. And what I've shown here in this first one is a slightly larger Earth, an Earth plus Moon incandescent blob. And what I intimated in my research was that the Earth, this primitive Earth-Moon blob, was very much closer to the primitive young Sun, very much smaller than what it is now, and totally different to what it is now. So if you can imagine a fragment, or not a fragment, a blob of material flung off the surface of this primitive young Sun, very similar to the sunspot activity that we see today on a yearly basis, happening on the Sun today, but different materials. So what I'm suggesting is that we have this whatever the Sun is made of, this blob of pure energy, whatever, plasma, whatever, that's flung off this surface of this Sun. That blob, as well as periodically the rest of the remaining planets, are also the same. This material, this primitive planet, along with the other planets, then gradually, over a very extended period of time, move away from the surface of the Sun, away from the influence of that high temperatures on the Sun. This material, this energy, then simply condenses to form matter. This is simply a reversal, as our next speaker I think will allude to. This energy, in Einstein's equation, if you increase the speed of matter, you convert it to energy. If you decrease the speed of energy, you condense it to form energy. It's just simply a reversal of Einstein's equation. Energy has no mass, or matter has mass. So at that moment in time, once that energy condenses to form matter, you then start to get mass. During this same phase, I envisaged this newly formed material condensed on this very primitive blob of Sun material, becoming gravitationally unstable, generating a wobble. I calculated that you need 400 kilometre thickness, which is about that scale of material, of this new molten matter, to be stripped off that primitive Earth-Moon blob to form a binary Earth-Moon planet, which is what we are now, a binary planet. The size of the moon and the size of the primitive Earth were roughly identical dimensions at that time, 1,700 kilometres radius, 3,400 kilometres diameter. We forget about the moon now. That moon comprised matter which had already been condensed. So the radius of the moon essentially stayed constant from then on. The Earth was still retained this highly reactive core material. I then envisaged this condensation of matter to continue to condense at the core mantle interface. New material will then forming the mantle. New material will then cause mantle swell. Mantle swell will then be transferred to the outer crust and cause crustal extension. By the time we get to the Permian period, we then reach a point where this newly formed continental crust, the ability to extend is exceeded, and we start getting fragmentation and breakup of this crust and opening up of the modern oceans. And this is a cross-section of the modern Earth, where we have mid-ocean rift zones, volcanic material being derived, upwelling from the being extruded along these cracks and being solidified on the sea, at the ocean floor. The fragments of the continental crust remain in position with deep roots. This is again a contentious issue in plate tectonics. The continents have very deep roots, where in plate tectonics this material is supposedly subducted in this very region where we have these deep roots, very, very deep, hundreds of kilometres deep roots below our continents. So that's in a nutshell. This next slide is an introduction to the next phase of this presentation. What happens to the continental crust, and in part the oceanic crust, when we increase Earth radius? And this is alluding to a mechanism for mountain building and seismic activity and volcanic activity, etc. Shown here is a cross-section of a primitive Earth, the Permian-Pangean Earth, at 50% of the present Earth radius, and the present-day Earth. I've also shown a little fragment of a primitive crust, just one small fragment, and this is about 5,000 kilometres diameter, about the size of the present-day European continent. I've omitted, for clarity, I've omitted the rest of the crust. So what happens when we increase radius is we get a progressive, we'll just see if that animation works, yep, we just get a progressive flattening of that surface curvature. Now this is a very important point to accept, is that you get a flattening of this surface curvature and also an extension of that component, that radial component through here, sorry, the chord length through here. This doesn't happen all at once. It happens over a projected period of time, over that full period of time. The elevation, the difference in elevation we're talking about is around about 580 kilometres of this material must collapse, progressively collapse. So as the Earth progressively increases in radius, you're getting first off, you're getting a slight super elevation of the continental material. As you get both sets of both crusts joined together, you get a super elevation in the continents, hence the continental crust. Sorry, the primitive continent, supercontinents, and within the adjoining areas, the areas of the continental seas, the depressed areas. As you then progressively flatten that crust, you get compression within those continental sea areas, compression, folding of these soft sediments, any jostling, you get mountain building and volcanic activity, and also introduction of metals and granites and volcanic rocks. I guess this is what I find throughout history, is that this is generally pulsed. You get super elevation, collapse, and also erosion of that crust, the elevated crust, and weakening of that central area, and collapse again, compression to form new mountain belts, extension, basin forming sediments, new sediments, compression to form new mountains, and so on. we'll just hone in a little bit closer to, and this is a schematic representation of what happens to the crust itself. Now, what's shown here is the continental crust, about 30 to 70, 80 kilometres thick, overlying the mantle, which is hot plastic, superheated, and the starting off of a shallow continental sedimentary basin and overlain by water, or by shallow seas. As you get radial increase, this is transferred to the crust as crustal extension. So you can imagine this as being, say, a piece of plasticine or a toffee or something. You stretch that over a very long period of time, you get stretching and elongation. And a very good example of the rocks that would form in here down in the foyer. If you go down the foyer, look at the floor, look out in the mall there. These gneissic rocks have a very stretched, elongate, attenuated fabric. This is typical of this environment. If you continue to stretch that crust, you then start getting faulting, what we call listric faulting along these margins. And a classic example of this is the Red Sea between Africa and Arabia, where the margins of this sea are fault bound, these classic listric faults. Continuing on with that extension process, we then get into a continental scale where we get a breakup of this and fragmentation to form the modern continents and the modern oceans, the modern ocean basins, and then migration.
And the other killer, and now going back to this BBC documentary that happened to be on this morning, is the big problem for them, as I may have said earlier on, is the oldest ocean floor based on this magnetic field reversal measurement, which they've looked at and measured that with various isotopes and whatever radioactive isotopes. The oldest ocean floor they can find in the mid-Atlantic is 180 million years, right? But the age of the Earth, for those that don't know, is said to be, based on other measurements, 4 billion years. So they know that this mid-ocean ridge has actually been created in the last 180 million years. Why is that? Why is we should be able to find some ocean floor. If you've got this Pangea supercontinent with all the ocean around it, and they know when that broke up 300 million years ago, then where's the rest of this ocean floor that's over 300 million years old? Doesn't exist. You can't find it anywhere on the planet. So this ocean floor has come into being in the last sort of 180 million, 200 million years. So all the geology that you look at like that shows that the Earth has expanded. And there's quite a lot of evidence, as I say, James Maxlow goes through it in his book. So the problem then becomes, the reason why geologists dismiss this and say, oh, so rubbish, is because they don't have a mechanism to explain it. They say, well, the Earth can't have expanded.
They do that a lot, don't they?
Yeah. So the Earth can't have expanded because how would it do it? How would it do it? And even though they know, and they say in the books, the Earth only ever had shallow seas, right? So when the dinosaurs roamed the Earth, you read the textbooks, it says there were no large oceans, only shallow seas, which I think maybe means like, I don't know, maybe up to 1,000 feet deep, 600 feet deep, something like that. Not these like great, sort of 6 kilometre deep trenches that you have now. Like the Mariana Trench, which are however many kilometres. I mean, I've got these figures in the book. I can't remember off the top of my head how they deep these trenches, but like kilometres deep. I think the deepest one is something like 17,000 feet or something like that. And they know this. They know that. So you've got. So where's all this water come from? So how did the shallow seas become? Deep oceans. And they'll say, well, the water was brought on comets, wasn't it? Oh, yeah, okay. We'll give you that one then. How are you going to measure that, though? How do you know when the comets... These comets that they see, that we can measure, and there's one fairly recently, comet Neowise, I think was the most recent one, which did become visible. We just managed to see it. I think it was in June or July. We went out and managed just to see it one night, just before it went away. Not a very good view. But if you were to measure the proportion of water in that comet, for example, was it like 1% water, 2%, 10%? What was it? How many comets would it take, and how much rock would they bring with them to get all that water?
Yeah,
Have you done those calculations?
exactly. Yeah.
Can you estimate it? And again, I don't think such a thing has been done. And while we're on about the oceans, let's think of another problem. And the only person that I could find that's written about this was Immanuel Velikovsky, and that was in an unpublished book. What do we know about the oceans? How about they're salty? Everyone knows that. Most people have experienced that. But yet, where does the ocean water come from? Well, the rivers flow into the oceans, don't they? And they fill up the oceans. So the rain comes on land, falls, and the rivers fill up the oceans. Right. So, how salty is river water then? When you get to the bottom? No, hang on. Rivers are freshwater, aren't they? There's no salt in them. That's why we have freshwater fish and saltwater fish. So that's a big mystery, isn't it? Where does all the salt come from? And there's a hell of a lot of it, isn't there? Doesn't come from the land, does it? Doesn't come from the land.
It's funny.
Can't do.
It's so obvious when but people don't question it.
Exactly.
We haven't. It's something that everyone knows.
It's such a basic thing, isn't it? Such a basic thing.
This is how they get you, isn't it?
Yeah. And again, so that in theory, then let's say that I think that you can even read it in some of the textbooks. There's something about the salt coming from the rivers or something. I forget the exact. I've got a quote in the book, but there's very, very little that I could find. And again, if any geologist wants to write to me and to read, educate me, please. That's what I'm about. I want to be educated. If I've made some terrible mistake in all of this, bring it on. Fix me up. But we know, just like you think of like the River Thames, for example, the bit that's near London, some of that is going to be freshwater and some of it is going to be salty because it's tidal, where London is just about. I don't know how far the tidal bit goes, but we know just from our own direct experience that rivers, that whatever rock they're flowing over don't get salty. I think there's one or two salty rivers somewhere in the world, I can't remember, just because all of their course, there's some type of salt in the rock, but by and large it's all fresh water, isn't it? We know that. That's why we call it that. So we have a problem. We have these deep oceans. Where did they come from? Those and why are they salty? And those are the two questions you won't find many answers to. So hang on then. So we've got so let's look at the things that are stacking up. We've got some other issues we haven't even got to yet as well. So where did the oceans come from? How are they deep? Why are they salty when we can't really explain that? And the Earth is expanding. What's causing that? So we'll go back to James Maxlow, for example. He says the Earth's expanding. Tick, yes, agree. How is it expanding, James? Let's see then. So we think that mass might be being created in the centre of the Earth. There's some mechanism which is creating mass in the centre of the Earth. Okay. So that means that if mass is being created, the Earth is getting heavier then. So to make the Earth expand, we've got this matter inside it, be somehow some weird nuclear process. There's a black hole in the middle or something, and mass is being sucked in from somewhere in the universe and spat out in the middle of the hollow Earth. Oh, sorry, I haven't got to that bit yet. Because James Maxlow doesn't think the Earth's hollow. I think the Earth is kind of hollow, but we'll get to that in a few minutes. So James Maxlow thinks there's matter being created. Now, going back to Neil Adams, who did these wonderful videos, and they are brilliant. They're really good. Clearly show this is what the truth is. But Neil Adams, you can't debate with him. He says that the Earth is expanding because of pair production. Now, he's not wrong on this pair production. There is a process in physics whereby, and it's to do with quantum physics, they say that spontaneously a particle can come into existence, or pairs of particles can come into existence out of the quantum foam and then create, a nucleus of an atom or something. I forget the exact thing, or a radiation particle, which then can form atoms and stuff. So Neil Adams claims on his website, and he won't budge on this, that the extra matter which is causing the expansion is created through a process of pair production. It's like he's talking about something which is the opposite of a black hole almost, like a white hole, if you will, where the matter is coming out. And of course, some people dispute the existence of black holes as well. But he claims all of that on his website, and you can go and read his articles, and he's been saying the same thing for years. But the only evidence that he's got of that, again, we're kind of back to the molten iron core. Has he been to the core of the Earth? No, he hasn't. So does he know that pair production is going on there? No. Does James Maxlow know that cosmic processes are creating matter in the centre of it? No, it's just a theory with no real evidence that he's got. It's just a couple of papers that say these things might be happening in the middle of a galaxy or something like that, which you can't directly see. So we're still left with this problem of what's creating the missing, what's making the Earth expand. How is it extra matter? And then there's another problem, which is another related mystery: the dinosaurs.